Hi everybody, thanks for checking out today's tutorial. Today we're going to discuss graphs of proportional relationships. So we've been working with rates and ratios and a little bit last section with equivalent ratios, which we set up into proportions. And today we're going to look at when we graph a proportional relationship, what that looks like. Okay, so today's learning target is I can determine whether quantities are proportional using graphs. Here is our key idea for the day, and we have a vocab word as well. It says graphs of proportional relationships. Two quantities, x and y, so remember our x-axis is the horizontal and our y-axis is the vertical, are proportional when y equals kx. Okay, we're going to use this equation, y equals k times x, where k is just a number and it's not 0. So where k is a number and it cannot equal 0. So if it's 1 or if it's 2, or in this case, y equals 2x, we just substituted 2 for k. Okay, so y equals 2x is an example. If you were given this equation, that's what this, if you were to graph this equation, that's what it would look like. The number k represents the multiplicative relationship between the quantities and is called the constant of proportionality. Okay? That's the relationship between x and y. That's what that represents, right? So, in other words, if I were to give you this equation and I were to give you a t-chart with some x values and some y values, okay? When x is 1, I want you to plug in 1 to this equation. Y equals, what is 2 times 1? 2 times 1 is 2. So that's how this gets you this coordinate point of over 1 from my x up 2. You'll see that that line, this blue line, goes through that point. Okay? I could give you another x value, like 2. If x is 2, y would be, well, what's 2 times 2? That'd be 4. So when x is 2, y is 4. So over 2, up 1, 2, 3, you see that that line is going to run through those points. Okay, and these are proportionate, right? How do I go from x to y? Well, I multiply by 2. I multiply by 2. If I were to go to 3, I'd multiply by 2 to get to 6. Right? Go over 3, up 6. And you'd see that if you kept going, you'd run into that point. So you can see that these are proportionate. We looked at this last section. And now we're looking at if we graph that proportional relationship, this is what it would look like. The other important idea that we need to take away here is that the graph of a proportional relationship passes through the origin. That's a big idea, okay? If your line does not pass through the origin, it is not proportional. So you got to make sure, and remember the origin is this point right here, 0, 0. That's probably important to write down. The origin is 0, 0. And if your graph if your line doesn't go through the origin, it does not show a proportional relationship. Okay, so that's also something that's key. All right, let's try one. It says, determine whether two quantities are proportional. Tell whether x and y are proportional and explain your reasoning. So here we have a table. Okay, what I want to do first is I want to plot the points in a table and then draw a line through those points. So I'm going to try to fit both A and B on this piece. So I'm going to make two separate graphs here. It looks like all my x values are positive and I only have one negative y value. So I'm going to keep that into consideration when I'm making this. Okay, here's my y-axis. Since I don't have any negative x's, I'm just going to start here. And my graph will look something like this. Okay. Again, this is my y-axis, and this is my x-axis. And I can just go by ones, because my numbers are relatively small. 1, 2, 3, 4, and so on. And when x is 1, so when x is 1, y is -2. So that would be down 2. So there's my first point, right? This would be -1, -2, so on and so forth. When x is 2, y is 0. So when x is 2, y is 0. When x is 3, y is 2. And when x is 4, y is 4. Right? Use a different color, hopefully, to show that a little bit clearer. And my line continues on and on and on. Okay? So there's my graph. And now I need to say, are x and y proportional, and then explain my reasoning. Well, really quick and easy, I can see here that this line does not pass through the origin. We just talked about that. This, to be proportionate, it has to pass through 0, 0. And this line does not. So right away, I can kind of stop here and I can say the line does not pass through the origin. So x and y are not proportional. And you could see that up here from this data, right? Last section, we talked about how to tell from a table if it's proportionate, right? So x is 1, y is -2. Is -1/2 equal to 2/0? Definitely not. Is that equal to 3/2? Definitely not. Is that equal to 4/4? Well, 4/4 is 1. Are any of these other values equal to 1? Definitely not. This is definitely not a proportional relationship. Okay, so you could just kind of tell by looking at this table. Let's look at letter B. Let's see if this one's different. Okay, we're going to start by plotting our points. It looks like I have all positive x's and all positive y's. So I'm just going to be using the first quadrant then. Making this kind of L shape because I have positive numbers to the right and positive numbers up. If you go by ones, you do not have to label that. So if you go by ones, I'm assuming if you don't label what you're going by, I'm assuming you're going by ones. Okay. So 0, 0, right there. 2, 2, over 2, up 2. 4, 4, 3, 4, 1, 2, 3, 4. And over 6, up 6. Okay. And then I will connect my dots. Sorry if it's not the straightest line. You should hopefully use a ruler or like the side of your book or something to make straight lines, but can't really do that with my digital pen here. And then let's look and see, is this a proportional relationship? Well, does my line pass through the origin? Yes. And are my data points equal? Are they proportionate? Well, is 2/2 equal to 4/4? Well, yeah, they both simplify to 1. Okay, so definitely I'm multiplying by 2 on top and multiplying by 2 on bottom. I'm multiplying by 3 here, and I'm multiplying by 3 here. So yes, these definitely are proportionate. So you could say the line passes through the origin, or this 0, 0 point. So x and y are proportional. Right? That's how you do those types of problems. Let me know if you have more questions on those. Next, I will have you pause to do 1, 2, and 3 here for the triad section. Go ahead and make your graphs similar to I did. Start by making your coordinates, and let me know if you need more help with that. Please pause now. Okay, just for time's sake here, I'm not going to make all 3 of these graphs, but like I said before, if you need some more help making them, let me know. Number 1 is no, they are not proportional. The line does not pass through the origin. Number 2, yes, these are proportionate. You can see as x increases by 1 each time, y increases by 4 each time. So I'm just multiplying by 4 to get from one to the next. And if you kept going in the negative direction, you would go through 0, 0 as well. So yes, for number 2. And then number 3 is no. Those points don't even make a straight line, so that's not a proportional relationship. All right, let's look at the second example where it wants us now to find a unit rate by looking at a graph. Okay, remember a unit rate, this is kind of a big hint. A unit rate has a denominator of 1. Okay, that's really important. The graph shows the speed of a subway car. So this is a subway car speed. Find the speed in miles per minute. Miles per minute. And when we're talking about a unit rate, we want to know how many miles does our subway car go per every 1 minute. Again, because we're looking for a rate that has a denominator of 1, a special rate called a unit rate. Okay, let's look and see. On my y-axis, I have distance, so how far I've gone. And on my x-axis, I have how many minutes I've gone by, or the time. So I'm looking for how many miles did the subway car go in 1 minute. All right, I'm going to come down here to minutes, and I'm going to find where it looks like it's going by a quarter of a minute, right? A fourth, a half, 3/4, 4/4, or 1. So here's 1 minute. I'm going to go up to where my line passes through, okay? And if I look over, that value it is gone in 1 minute. My subway car has gone, looks like it's at a half, so a half mile. Okay, so I've gone 1/2 of a mile in 1 minute. That's and that's our answer. Okay? I found the speed in miles per minute. We've gone a half mile in 1 minute. Okay, that seems like it's a pretty good speed. Let's try it now. Please pause and see if you can try this one on your own. All right. It says, does your answer change when you use the point 1/2, 1/4? Remember, x always comes first in a coordinate pair and then y. So when x is a half, right here, and y is a fourth, so go up a fourth of a line. So that's right here, right? 1/2, 1/4, that's this point right here. Does that change? Does your answer change to find the speed of the subway car if I use this information and explain? Well, again, if I'm trying to find a unit rate, this is, I've gone 1/4 of a mile in 1/2 of a minute. All right, this is half of a minute, and this is 1/4 of a mile. Does it change? Well, if I want to know, I don't want to know how far I've gone in a half minute. I want to know how far I've gone in 1 minute. So how do I go from a half to 1? I just multiply by 2. So if I multiply by 2 on top, 1/4 times 2 would give me 2/4, which is the same as half. So does my answer change at all? No, definitely not. I'm still going 1/2 of a mile in 1 minute. And that makes sense because it's still on this line. This point is on the same line as my other point was. Right? So it's proportionate. My speed is still the same. All right, last example. It says the graph shows the area y. So on my y-axis, I'm talking about area in square feet, that a robotic vacuum cleans in X minutes. Have you ever guys seen those Roombas before? They're kind of cool. I don't have one, but kind of look fun. So it's talking about the area that a vacuum cleans in a certain amount of time. Find the area cleaned in 10 minutes. Okay. Well, let's look at my graph. It shows me minutes. I've got 1 minute, 2 minutes, 3 minutes. It doesn't go all the way to 10 minutes. So how can I figure that out? Well, it looks like this line passes through the origin, and it looks like for every half I go up, I increase my minutes by 8, or my area by 8. I'll mix that around. For every half minute, I increase. So every time I go up on my X by a half, I increase by 8 in my Y, or by my area. Okay, so let's see if we can figure out how much. If the graph doesn't show 10 minutes, let's see if I can figure out how much area is cleaned in, let's say 1 minute. Okay. So for every 1 minute that goes by, I can clean 16 feet. Okay, so let's write that as 16 feet, and since it's area, it's squared, per every 1 minute. Okay. Every 1 minute that goes by, the robot vacuum cleans 16 square feet. Well, I want to know how many square feet is cleaned in 10 minutes. So I can just set up this proportion. How do I go from 1 to 10? Well, that's pretty easy. I just multiply by 10 on top and bottom. 16 times 10 would be 160 feet squared that I can clean in 10 minutes. Okay. You could also think about writing this. Another way to solve this is to think about writing an equation that goes with this line. Remember before we talked about the equation y equals k times x? Well, how could we find this letter k? How could we find out that constant of proportionality? Well, it's just kind of similar to what we did, but we're looking for per 1. So if you can write that unit rate like we did here, y equals 16 feet per second. So it would be 16x, right? For every 1 minute that goes by, it can clean 16 feet. So if I wanted to know how much I can clean in 10 minutes, I could just substitute in 10 for x here. Y equals 16 times 10, because my 10, or my x, stands for minutes. So 16 times 10 would give me 160, just same as what I got up here. Okay. All right, that is an introduction to Graphing proportional relationships. This is just the start of it. We'll get a little bit more involved with graphs this year. So if it's still a little confusing, don't feel bad. This is kind of a lot of new material, and we'll just practice it together and continue to grow and get better at it. Okay? Thanks for checking this video out, guys. I'll see you later.